Okay, so we actually have to show that this is always equal to 0. Okay, so it's going to be a little bit messy, I have a feeling. So first of all, to start off, is sine x sine y, and then y z, and then x z. So the common base is simple: sine x sine y sine of z. So this one with the xy, now it's going to be multiplied by sine of z. And we have the compound angle of x minus y. It's got the y and z, so this is going to have the sine of x. There's an extra factor that needs to be multiplied. Zx is going to have a sine of y. Okay. So now it's going to really explode, right? Because of the fact that if you use this compound angle on these three terms, it's going to get huge, really, really long. So let's see if something else we can do here. To me, this could look like, right, the first two terms could look like an expansion of one of the compound angles. But sine, sine, and then sine, sine, unfortunately, everything is just sine here. If it was sine, sine, and cos, cos, maybe we could have done something. But it's not that. So unfortunately, we have to expand. Right. I say unfortunately because it's gonna get messy here. Sine of z, so let's expand that out, and you get sine x cosine of y minus cosine of x sine of y. Expand sine y cosine of z minus cosine of y and sine of z. Okay, sine of z cosine of x minus cosine of z and sine of x. Okay, so we have xyz here, positive xyz. Is there going to be a minus xyz? Yeah, so if you expand that, that's going to cancel out with this. Do you see that? Sine of x, y, z. So let me actually, we know that this and that's canceled out. So let me write out the rest. This here is, you have to be careful with the z, x, y, z. Sine of z, it's a minus sine of z, cosine of x, and sine of y. Okay, that canceled out. We still have this left over. Sine of x, sine of y, and cosine of z. And here we have sine of y, sine of z, cosine of x. So these two are exactly the same, they cancel out. Lastly, sine of y, cosine of z, and sine of x. Okay, exactly the same, cancels out. So the numerator turns into a 0. So the whole thing is indeed 0.